KP the Math G here. My goodness, it's been a week since I have done my last video. We've been working on a couple of gardens here recently, doing a lot of yard work, and trying to just keep everything looking good in the yard. Been doing a lot of planting, so yeah, I've been kind of busy here recently, but it's, we've got a little time to do some videos and some more. So I'm gonna try to get, I'm gonna get this one in today, but I'm gonna try to get maybe a couple more in. This will be the 129th video. So let's get started. I'm doing a couple of questions off of this one. It's the 2013 free response question number 3, and I'm just going to read it to you. Instead of trying to write all of this on the board, I just wanted to put this up here. You see that T is in minutes and that C at T is in ounces, and what it has to do, it says hot water is dripping through a coffee maker, filling a large cup with coffee. The amount of coffee in the cup at time T, where T is between 0 and 6, including 0 and 6, is given by the differential function C. The differential also means it's continuous. The function is continuous, where T is measured in minutes. Selected values of C at T measured in ounces are given in the table above. We want to look at part B. Is there a time T between 2 and 4 such that C prime at T is equal to 2? Alright, so this would be in ounces per minute. Alright, the derivative is equal to 2. That's what we're asking. Alright, so between 2 and 4. So let's look at that. Between 2 and 4. Alright, so what we really want to look at here is that there is, we want to look at C at 4. Alright, this is kind of like, this is the slope, okay? Alright, so C prime at T, actually, yeah, is equal to C at 4 minus C at 2. That's a C there. Okay, C at 2 all over 4 minus 2. Now, one thing I noticed that these two end in an 8, so I know that those are going to subtract off. So what we have here is 12.8. 12.8 minus 8.8. Well, and then we know that 4 minus 2 is 2. And so this is actually 4 over 2, which is 2. So being that this is differentiable, we know that C is continuous, okay, throughout from 0 to 6. And being that it's differentiable and continuous, we know there is at least one. Now what they're picking on here, that's what they want to see that from you here, is that they want to find out if you know what this theorem is, that there is a certain theorem. Is there a time T in between, somewhere between 2 and 4, at which C prime at T is equal to 2? Well, that, ladies and gentlemen, happens to be by the, if you thought of mean value theorem, you are absolutely correct. By the mean value theorem, there is at least I'm not going to be able to write this out. Let's write it out over here. Sorry about that. there is at least one time at which C prime at t equals 2. Now, you might want to say that C is differentiable. Alright? Somewhere in here you say C is differentiable. C is differentiable, which implies that C is continuous. Okay, continuous. Okay, I had to abbreviate there. They want to know, I mean, this graph, is this broken anywhere? No, it's not, because it says very plainly that C is differentiable. And that implies that C is continuous on the interval, even from 0 to 6. Okay, we're looking at from 2 to 4, so even there, if it's differentiable from 0 to 6, it's differentiable from 2 to 4. And so this is a ploy on the mean value theorem. Is there a time at which C prime at t equals 2? Okay, so that's what you're doing on that part there. Alright? Alright, let's erase this. Let's put something else up here. I don't think we need the table. We're not going to need the table anymore. I'm not sure about that, but we're going to look at D now. Just a little brief idea. If I have time to look at A and C, we will, but I would like to think maybe we can, let's look at D first. And there's a reason for this, for us to look at D. Let's see if I can find, I put markers here and there. Here we go, let's try this one. Okay, now it says the amount of coffee. Alright, so the amount of coffee let's see, in the cup. Okay, in the cup, in ounces. Alright, it's modeled by I guess I spelled model correctly, yeah. Now this is modeled by well, 16 minus 16e to the negative 0.4 t. Alright. And we need to find the rate, so find the rate. And I'm going to abbreviate. Now what we're finding the rate is which the amount, at which the amount of coffee in the cup is changing. Alright, we're just going to say at t equals 5. Okay. Alright, now I know I abbreviated in between that, but if you look at this 2013 free response question 3, you'll see it more in detail than mine. But now, what's a key word here that you can hone in on immediately? Yeah, if you said amount, you're absolutely correct. Alright. Now, another word. What's another word? I'm about to block it in. Rate. So if B at t is the amount, and we want to find the rate at which this rate of change at t equals 5, what do you think we need to do? If you said find the derivative, you're absolutely right, because amount turns into rate when you take the derivative. Anytime you have amount, now if you have the rate, then if you wanted to find the amount, you would have to take the antiderivative. Okay? But you have an amount and you want the rate. Alright, well, I gotta find B prime at t. Well, a lot of times it's given the other way. The rate is given by this. B prime at t is equal to blah blah blah. Then you find the amount B at t. Something like that. It's so you might, or it may be B at t, and it may be given to be a rate. So you just take the integral of B at t. Alright, so sometimes it goes from rate to amount. How much? You're already seeing how much coffee is in the cup. Alright? At t equals 5, we want to look at the rate of change. Okay? And maybe how fast the coffee is going into the cup. That's what we're really looking at. The rate of change. Okay? Alright, so let's do that. And I'm going to do this by hand. B prime at t. Now we know that the derivative of a constant is 0. Okay? Alright, minus sign. Now we know that the derivative of e to anything is e to that thing, and then of course the chain rule says you got to take the derivative of that part of it as well. So we still keep the 16. So 16 times e to the negative 0.4 t. And then we want the derivative of this part right here. Alright, so don't forget that. Don't just put this part down and let that be it, because you've got to remember, you've got to find this derivative as well. Well, the derivative of this is just negative 0.4, isn't it? Because you just take the t off, right? Alright, so that's what that is. And then when you multiply this together, okay, I want to say you get a positive 6.4. Now, let's see, I'm thinking that's right. 6.4 negative times a negative. Okay, 6.4 e to the negative 0.4 t. Alright. And then, of course, when you plug in 5, you're going to get your answer. Okay. So, anyway, you plug that in. I think they move this down in the denominator, which means it makes this exponent positive. So, anyway, this is 6.4. You can leave it like this. It does not matter. E to the negative 0.4 times 5. Alright, and actually when you get this is actually 4/10 times 5. 4/10, okay, negative 4/10 times 5, which, remember, this is so negative, did I do that right? 5 goes into 10 2 times, and now negative 4 over 2 is negative 2. So this is negative, I'm sorry, it's 6.4 e to the, what, negative 2, which is 6.4 over e to the positive 2. Now whether you had to leave this or not, now this would probably be, this is in the ounces. Let's see, I know the amount is in ounces. I don't know, is the rate in minutes? I don't know. Yes, no, I don't, yeah, ounces per minute. Yes, it is. It is given to be in minutes. Okay. Okay. I guess they meant minutes as well, because I don't see minutes in part D at all. But I guess they were just going by this model up here too. Anyway, ounces per minute. So there it is right there. Alright, so, and you don't have to figure out what e to the second power is or anything like that. I don't even know if you have to put this down here. They do it, but there again, I don't think you have to worry about that. Okay. Alright. Okay. I thought I would show those two. Just know that when you're looking at amount, you want to take the derivative if you're looking for rate. If you already have the amount and want the rate, you got to take the derivative. And I know sometimes you wonder, when do I take the derivative? When do I take the antiderivative? A lot of times you're given the rate. Most of the time you're given the rate and you're asked to find the amount. Okay, well, that means you take the antiderivative over whatever time it is. Okay. Okay, so whatever time they give you, from time 2 to time 4, from time 0 to time 6, you know, so whatever they give you there. Alright. If you're looking for rate though, you already have amount right here, and just take the derivative. Okay. And sometimes, you know, even at this late stage in the game, sometimes, oh, when do you take the derivative, when you take the antiderivative? Well, that was one reason I wanted to give this. Okay. So just look at those keywords right there. All right. That, to me, that helps an awful lot. I may take time to do another one. Okay. I know this is all I really had planned to do, but just kind of a quick review over those other two. Let's see, what does they say? Find C prime. Alright, so we want to find, okay, A part. Find C prime at 3.5. Well, alright, 3.5 seconds. So we're looking, well, again, right here. And there you go. I think we found that to be equal to, because you want to get between, somewhere in this, like this. 3.5, you could actually do 4 and 3 if you wanted to, like that. Let's see, I think that's what they do too. Yeah, that's probably the best choice, actually, right here. Right here, 3.5 is somewhere between here and here. It's differentiable, so we know that we can do that. So then we'll just simply say that this is C at 4 minus C at 3 over 4 minus 3, which is 1 down here in the denominator. C at 4, 12.8 minus 11.2, and when you get the final answer, it is 1.6. And don't leave it at 1.6, it is ounces per minute. So you just, that's all you're doing, ounces per minute. Okay, that would be A. Alright, I'm just kind of going over these quickly. I didn't really intend to do that, but since I already have a little time, and since I haven't done a video in a while, that would be a good opportunity there. Alright, I just want to just look at this. I'm not really wanting to, you know, I haven't planned to do this. What does this mean right here? 0 to 6. I want to say that is a 6F. What are we finding here? Alright, this to me gives it away. Alright. It's an average. It's an average. Average amount. So this is dealing with amount here. Okay. Let's see. Average amount of coffee in the cup. Okay. On this interval. Okay. Average amount of coffee. In ounces. Right, if you want to mention that, you probably need to mention that on the interval. Okay, on the interval. Alright. Now remember, you can write an interval like this if you want to. Or you can write an interval like this and put the equal sign between there. Alright, either way is fine. It's average though. Okay. They were wanting you to do that by the let's see, 3 midpoint. Yeah. Okay. So what you would do is, well, here you pick 1. Here you pick 3. Here you pick 5. The middle between 0 and 2 is 1. Between 2 and 4 is 3. Between 4. And then you would just multiply those. And then the interval, of course, is going to be times 2. Okay? Times 2. 2 times this. 2 times this. And then 2 times this. I do believe that is correct. Yes. Alright. So you're taking this delta t is 2, delta t is 2, and delta t is 2. Okay, times this, times this, times this. That's what the midpoint is all about. Okay. All right. Well, that's all I have for now. And you've probably seen this on several videos, but this is good review. I know that a lot of you are graduating. My daughter is actually graduating, I want to say May the 6th for her. Yeah. So it's May the 6th for her. I don't know when you graduate or anything, but I do know that the test is on the 13th if you are an AP student. If you're taking regular calculus, whenever your semester ends, I want to say that that's probably in May sometime, so this month. So yeah, so we'll be out, my wife and I will be gone from the 5th to the 7th, and then we'll probably be back on the 8th, and I'll probably do some more videos, and I'll probably see how many I can do between now and the time you got to take that test. I know time is short for you, and I may continue videos after that. Who knows how many videos I'm liable to come up with, you know. But I mean, my goal is to get up to 200 maybe or more. Ever how many I want to do, but 300, I don't know. But right now, one at a time. KP the Math G, just getting ready to sign off. If you want to subscribe, please subscribe to my videos, to my website there, KP the Math G. If you want to make a comment, please feel free to do that. I've been getting some really good comments. I don't get that many, but every once in a while I get one, and I really enjoy that. And hit that like button. See, I'm already smiling. Hit that like button. But I hope this helps you out. This is not about me or my glory. It's about you and what you can do on that test. Really work hard. If you are an AP student, really you worked all year. I know you're getting ready to graduate, and you'll probably be done graduated, some of you, even before you take the test. So put your all into it still. Okay. These teachers work hard. These instructors, these professors work hard for you. Do your best. Okay, do your best on that test. Okay, KP the Math G signing off. Ladies and gentlemen, have a great day.